So this is the midterm review now. So we're going to find the value of x in this equation. So you can see the midterm is going to cover all the topics that we did all year. So this is all the way back from Unit 1. So we can see this one's going to be a little bit tricky because usually we're used to seeing a number out front of the parentheses. Here the negative sign is in front of the parentheses. So we do have to distribute the negative sign. So 4x plus 2 minus 3 minus 3x equals 7. We're going to see our like terms on one side of the equal sign is going to be 4x minus 3x is 1x. I'll just leave everything else as is for right now. We're going to go one step at a time. Then we got 2 minus 3 is negative 1. I'm going to drop the 1 in front of the x because 1 times x is just x. And I got to get the x by itself, so I'm going to move this negative 1 over by doing the opposite. I'm going to do plus 1 both sides. So I'm going to get x equals 8. And there we go. That's our answer for number 1. For number 2, Kendall bought 6 notebooks and 3 pens for a total of $27. The cost of one notebook is $1.50 more than the cost of one pen. What is the combined cost of one notebook and one pen? All right, so this one's pretty tricky, but so let's see. We got 6 notebooks. I'm going to call the notebooks X. 3 pens. I'm going to call the pens Y. So I can see I've got 6x plus 3y equals $27. All right, that seems pretty solid. So then over here, the cost of one notebook is, so 1x is means equals, 150 more than the cost of one pen. So 1.50 plus one pen. All right, so we're almost ready to roll. So I'm going to make things a lot easier on myself by looking at this equation and saying I can divide all of those by 3. So I'm actually going to do that to get 2x plus y equals 9. All right, so I've got this equation. What I'm going to do is do a little substitution. Since I know that 1x is 150 plus 1y, I can go ahead and plug that in for x here. So 2, 150 plus 1y plus y equals 9. And now I can distribute. 2 times 150 is $3. 2 times 1y is 2y. Plus y equals 9. So I can go ahead and combine my like terms again. So 3 plus 3y equals 9. I'm going to go ahead and subtract 3 from both sides. So that's going to give me 3y equals 6. And I'm going to divide both sides by 2. Sorry, not 2, by 3. I was thinking about the answer already. So I get y equals 2. All right, so it turns out that y equals 2. This means that the pen is $2. All right, so I know y equals 2. So what I'm going to do is take my y equals 2. Plug it all the way back up here. And say 1x equals 150 plus 2. So x equals 350. So a notebook is 350. All right, final part though. What is the combined cost of one notebook and one pen? So 1x plus 1y equals what? So we get 350. For one notebook plus $2 for one pen. And that's going to give $5.50 for the total. So there we go. So that's what we got. All right. For number 3, solve this equation for h. So this one is one of the literal equations. So again, we're trying to get h by itself. So we see right now h is not by itself. I see I'm dividing by 3. So what I'm going to do is multiply both sides by 3. So I'm going to do that at first. So we get 3v equals s squared times h, because that's going to get rid of the 1/3. H is not by itself, so I'm going to divide both sides by s squared. So we get 3v over s squared equals h. And I can see since now the h is by itself, I'm done with the problem. That's all we want to do. So a little bit of a literal equation. We can see 2 and 3, those ones were pretty tricky when we were doing the tests back in Unit 1. But we want to revisit them and we want to make sure that we get them solidly so that we're ready to go for some of our more advanced concepts this year, maybe some more of the advanced concepts in Algebra 2. All right, for number 4, we got another tough one. We got to solve the inequality and graph it on the number line. So this is a really big inequality, but we're going to be calm about it. We're just going to go one step at a time. So we're going to do all of our distributing. So 5x plus 5 plus 3 is greater than or equal to 4x plus 3x plus 6. Remember, when we distribute, we multiply, we don't add. We'll combine all the like terms that we see. So here there's some like terms. Here's some x's that we can combine. So 5x plus 8 is greater than or equal to 7x plus 6. Now, when I do inequalities, I like to put the x's all the way on the left side. So I'm actually going to do minus 7x on both sides. You may choose to do it a little bit differently, but for me, I like to put them all on the left side. So negative 2x plus 8 is greater than or equal to 6. Since I put the x's on the left, I have to put the number on the right. So I have to do minus 8x on both sides. Oops, wrong slash. So I'm going to do minus 2x is greater than or equal to negative 2. And I have to divide both sides to get x by itself. So I'm going to divide both sides by negative 2. So I get x and 1. But since this is a negative, remember, if you divide or multiply by a negative, we have to flip the sign. So we're going to flip that sign. So instead of a greater than sign, it's going to be a less than or equal to sign. So I've solved it, but I haven't answered the question because the question says to graph it. So what we're going to do is we're going to go right to 1, since 1 we got as our answer, and I got to put a dot. So I know I'm at 1. So to decide which type of dot to use, remember, if it's got the little or equal to sign, these are the closed dots. So I'm going to fill in my dot. If it was one of these, then we would do the open dot. Then I got one more thing I got to do. I got to decide which way I'm going to go. So in this case, I've got a less than sign, and this is the reason why I like to put the x's on the left side. I can just kind of follow the sign. So the arrow looks like it's pointing to the left. So we're going to go ahead and just go right to the left. Again, if I want, I can double check by checking a number. So if I tried a test value, if I pretended that we had 0, so 0 is less than or equal to 1 is true. So I would go from negative 1. So since that's true, I would go towards 0. So I would start at 1 and then go towards 0. So I could also try that out if I wanted to pick a test value or if I had the x on the other side. So that's what we got for that one. All right. So then for number 5, we have to solve the absolute value equation. So first thing we got to do is ask, is the absolute value by itself? Yeah, the absolute value is by itself. There's nothing outside of the absolute value. So I'm already ready to split this up into its two equations. So 8 equals 5 minus x. Just get rid of the absolute value bars. And then for the other equation, we're going to do negative 8 equals 5 minus x. Now I got to solve each of these. Luckily, you solve them the same way. So I'm going to minus 5 on both sides. To get 8 minus 5 is 3 equals negative x. And then I have to divide both sides by negative 1. So I get negative 3 equals x. On the blue side, I'm literally doing the exact same steps. I got 5. I have to do minus 5 both sides. Now my number is a little different. This time I get negative 13. Then I'm going to divide both sides by negative 1, just like I did over here, to get 13 equals x. And those are my two answers. So we're all set. There we go. All right. Now we are done with Unit 1. So now we're doing some Unit 2 stuff. So again, Unit 1 was probably the tricky unit for a lot of people. So there may be some things to practice with some of the absolute values, all the inequalities. I mean, even the literal equations, we could use a little bit of extra work on those. But we were doing pretty good on Unit 2. So for Unit 2, this is nice because we got to do 3 different things. First thing we're going to do is graph it. So to graph it, we're going to look at the y-intercept. So we're going to start at negative 2. And then we're going to use the slope to say we're going to go up 3, right 1. So 1, 2, 3, 1. Now that I got 2 points, I could draw the line if I want to keep going. 1, 2, 3, 1. 1, 2, 3. I could go down and back. That would also be okay. But I'm going to go ahead and draw the line. And that's going to be all good. Part B, identify the slope. Well, we already did that. It's 3. Part C, identify the y-intercept. We already did that too. It's -2. So nice and easy. So there we go. And again, we were pretty good at these ones, so we just want to make sure to maintain how good we are at these ones. Again, if you want to graph them in your graphing calculator, you're more than welcome to do so. Number 7, what's the equation of the line that passes through -5, 0, and 4, 3? So here we've got x1, y1, x2, y2. Since we've got 2 points, we kind of know if we want, we can just do y2 minus y1 over x2 minus x1 to get the slope. So if we plug them all in, so that's going to be 3 minus 0 over 4 minus -5. So 3 over 9, which is 1/3. And then we can use y equals mx plus b. And we're going to use our first points and our slope. So 1/3 is m. And we're going to use this one as x and y. So we get 0 equals 1/3 times -5 plus b. So 0 equals -5/3 plus b. We can add 5/3 to both sides to get 5/3 equals b. And that gives us our final equation. Y equals 1/3 x plus 5/3. And so there we go. So we've got our nice little thing. And we've been pretty good at these ones. This is also one that if we wanted to, we could do it in our calculator. Let me bring up Desmos. So in this case, if we want to use the table, we can put in our 2 points, which I forgot the 2 points, -5, 0. And then 4, 3. I think those were the 2. Yep. Let's make both the dots appear. There they are. And we can type in our little code, y1 tilde, mx1 plus b. And we can see that, yep, we get the same answer. Now, again, this is in decimal form, so you got to be careful because this is a decimal, but it is the right choice. We're going to save all this. Point 3 repeating is 1/3. And then 1.6667 is 5/3. So we do have the slope and the y-intercept. So again, there's m, there's the slope, there's b, there's the y-intercept. If we wanted to use the fancy graphing calculator, again, we can do that as well. We're going to have to go into the stat menu, which I just did this one for something different. Clear, enter. So we're going to put in our 2 points. 5, that's not right, -5. I think 4. Clear, enter. And then 0 and 3. Let me double check to make sure those are right. 4, 3, -5, 0. Yep, all right. So we'll hit stat over number 4 for the linear regression. And we can see we do get the same answer. So if we do our linear regression, we get the same thing. So we all agree, no matter which way we do it, if we do it by hand, if we do it with Desmos, if we do it with the big graphing calculator, we're still going to get the same answer. So there we go. If you're doing it with this one, just remember 0.3 would not be a correct choice. You'd have to do 0.3 repeating with the little line if you want to keep it as the decimals. Same deal here. 1.6 is not correct. 1.6 repeating with the little line is what you'd want to do. All right, number 8, what's the equation in standard form of the line that has x-intercept -4 and y-intercept of 3? So in this case, they're telling us we have to use standard form. So we're going to start with standard form, which is ax plus by equals c. We did a pretty decent job when we had this one on the test. We know that if it's got the x-intercept of -4, that's got to be the b value. So it kind of flip-flops. If we've got a y-intercept of 3, we want 3 to be the a value. And then c is going to be the total. We can get that if we just multiply those two together. So -4 times 3 is 12, and we'll get 12, and that'll be the final answer. Again, the way that we would do it is we kind of work backwards. I'm just going to plug them in right now just to double check to make sure it looks good. I mean, you could throw it in your graphing calculator if you want, but to double check, if I have an x-intercept of 4, this would be x is -4 if y equals 0. So let's see if that's what happens. 3x plus -4. Oops, this is actually -12. Good thing I double checked. -4 times 0 equals -12. So 3x equals -12. Divide both sides by 3. X does equal -4. Likewise, here for a y-intercept of -3, that would mean that y equals 3 if x equals 0. So again, we can plug those in. So 3 times 0 plus -4y equals 12. So we get -12. -4y equals -12. Divide both sides by -4 to get y equals 3. So that does check out. So that does work in both cases. Again, you can also do this exactly like we did the last question if you really want. It's going to be a little bit harder because you'll have to convert, but you do have 2 points. This is the point 0, -4, and this is the point, oops, other way around. This is the point -4, 0, and this is the point 3, 0. So you could actually, so not that way. Y-intercept of 3, 0, 3. So you could actually go ahead and do the same thing that we did in the last one and then just convert it back into standard form. That's also possible. Obviously, much quicker to just get the answer, but this is why it works. All right. For number 9, write the equation in slope-intercept form of a line that passes through 2, -1, and is perpendicular to the line of y equals -2/3 x plus 6. So we see we got perpendicular to this line. So the current slope is -2/3. So the perpendicular slope means we're going to take -2/3 and we're going to flip it. And then we're going to switch the sign. So that's what we do to get our perpendicular slope. So we've got 3 halves. All right, so we know that that's the new slope. So we go back to y equals mx plus b. We're given our points, so we're given the x and the y. So we have -1 equals 3 halves. -2 is x plus b. Now, the thing that's a little bit different with this one versus the last one we did that was just like this is this time when we multiply these, we just get a nice number. We just get -3. So we don't have a fraction like we did with the last one. Add 3 both sides. So we get 2 equals b, which means final answer, y equals 3 halves x plus 2. Now for this one, since 3 halves is a nice decimal, you could just make that 1.5 if you wanted to work with 1.5. But that's what we got for number 9. So there we go. For 10, now we're into Unit 3 stuff. For the map relation, identify the domain and the range. So remember, domain is going to be just like the x's. So if I look at the domain, we've got -2, 0, 1, and 3. Those are all the x values. Identify the range. Those are all the y values. So we've got a -3, 1, 3, and 4. So there we go. So we got the domain and the range. That's it. We're done. Oops. So notice this one would not be a function. They didn't ask, but there's 2 arrows from -2. So it's just a relation, not a function. Number 11 says one of the following is not an arithmetic sequence. Circle it to explain why they're not arithmetic sequences. So for arithmetic sequence, remember the idea here is we're adding by the same thing every time. So let's double check. So for the first one, we're going 2 to 5, that's plus 3. For this one, we're going 5 to 10, that's plus 5. So this one is out. We're adding different numbers. So that one can't be true. For B, plus 5, plus 5, plus 5, plus 5, and then minus 5. So here we can't pick that one because here we are adding and subtracting. You can only pick one. So either always adding or always subtracting. Can't mix and match. For part C, we're going to do minus 2. Then we're going to go back 4. And so right away, again, we can take that out because we are subtracting different numbers. So it can't be that one. So D is the only one that's left. If we don't want to double check, add 6, add 6, add 6, add 6, and add 6. So we're always adding 6. So since this one is plus 6 every time, that's why it is an arithmetic sequence. So that one's the good one because we're just adding the same number every single time. For number 12, it says Angel works on the weekends. Each day she earns a set amount plus an hourly wage. So part A, write a linear function that Angel can use to determine her pay. So P of X equals MX plus B. So to get the slope, I'm going to check as I go up 1. I'm going to go up 8. So P of X equals 8X, because that's the slope. So the slope is going to be 8. And then I got to get B, I got to get the y-intercept. To get the y-intercept, I'd have to go back to where we're at 0. So to do that, I would go minus 1. And instead of going plus 8, and then going backwards, I would have to go minus 8. So then that would get me to 5. So 8x plus 5. There we go. Now, if I wanted to, I could throw this into the calculator just like we did with one of the other ones. I'm going to do that in one of the two. So I'll do it in Desmos. I won't do it in the graphing calculator for this one. Let's see. 1, 1.5, 2, 2.5, 3. And we were at, what, 13, 17, 23, 27, 33, I think. Is that what we had? Nope. 13, 17, 21, 25, 29. All right. And we can see, yeah, we get the same answer. I'm going to grab that. Again, if you're using your TI calculator, use the stat menu just like we did before. So there we go. All right, part B, how much is Angel's hourly wage? Now we need to actually analyze her equation here. So the hourly wage is how much she gets every hour. So hourly wage is a rate, which means this is the slope. So all I got to do is find the slope. It's 8. So she gets paid $8 an hour for this job. What's a reasonable domain for the situation? So again, if we look at this one, it says that she's going to work on the weekends. So for a weekend, we can think how many hours would make sense for a weekend. So if you work for 8 hours a day, and the weekend is 2 days, so 8 times 2 would be up to 16 hours. So if she worked all of Saturday and all of Sunday, 2 full days, that would be about 16 hours. So we would pick this one. Again, 36 would be a little bit too much for 2 days, and 72 and 148 are unreasonable choices. That's more hours than exist in a weekend. And then lastly, part D, if Angel works for 5 hours, how much would she earn? So for 5 hours, we would just plug the 5 in for X in this equation up here. So we would get 40 plus 5. So for 5 hours, she would make $45. So that's how much that she would earn in 5 hours. Again, if you didn't want to actually do the calculation, you could actually complete the table. You could keep the table going. So you could say for 4, we would add 8. So 29 plus 8 is 37. For 5, we would do plus 1 more, so plus another 8, so that would take us to 45. So we can double check it. There's a lot of different ways to do this question. Obviously, I would prefer the function way, but you want to do it the way that makes the most sense for you. So if it makes more sense to continue the table on, go ahead and continue the table on. Again, that's something that you want to do in real life too. If that's the way that you want to think about it, by just going hour by hour, that's great. That's the recursive way to do it. If you want to do it explicitly, you can do it explicitly. All right, so for 13, what value of k transforms f into g? So we're going from f to g. So I'm starting at 4. Since we're adding, we're just going up or down. We have to go down to here. It looks like we're going down 3, so -3. And that's it. All done with 13. Oops. All right, for 14, which R value suggests a strong positive correlation? So for positive, we get rid of our negative choices. For strong, we want to pick things that are close to 1 or -1. So the closest one to 1 is going to be this one. This one is close to 0. So this one would be a weak choice. So that would be weak because it's close to 0. For 15, we've got our scores for 6 students. We have to decide if we have a positive or a negative correlation. So as these are going up, so up, 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 these ones are going up, 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 flat. But for the most part, it looks like as science goes up, E-N-C, yeah, that's right. As science goes up, English goes up. So since they're both going up at the same time, that would be a positive correlation. So negative would be if one went up and the other went down. Can the data be used to show correlation? That's a no. So again, if it was causation, that would mean everyone who is good at science is automatically good at English. Which is true sometimes, and the data shows that for the most part, it looks like people that are good at science are also good at English. But it's also possible that there's more than 6 students in the class, and maybe some of them are really good at science and really bad at English, or vice versa. Maybe they're really bad at science but really good at English. So that would be a no for that one. For 16, we want to estimate the solution for the systems of equations as shown in the graph. So this is a pretty quick one. We just want to see where the two connect, because remember, where the solution is where those two things intersect. So that's a little tough because it's not exactly on a line. So we got to be a little bit careful with our estimation. So in the x's, it looks like it's a little less than 1. So maybe like 0.8-ish. So I'm going to say 0.8 for the x. And then in the y, it looks like we're between -1 and -2. So maybe like -1.2-ish. So somewhere around there. I don't know. As long as you get close. Maybe 3/4 and -1.25. Yeah, those all look pretty reasonable. So as long as you're around there, again, we're just doing an estimate. So since we're just estimating it for an estimate, we just have to be close. We don't need to be exact. What would be wrong answers? Anything above 1 would be a wrong answer. It's clearly not past 1. Anything before -1, so anything above -1, we can see that the answer is clearly below -1. Those would all be wrong answers as well. You want to be in this box where we're at. Again, even a half and -1.5, that still looks a little iffy. So we can kind of make a good estimate based on those values. All right. So for number 17, each day at the bakery, Jack bakes cakes and helps out at the counter. So we have to make a scatter plot of the hours Jack spends at the counter as a function of the number of cakes he bakes. All right, so it looks like we're making a scatter plot, so we can do a scatter plot. That's pretty nice. We just plot the points. So 2 cakes for 4 hours, 3 cakes for 4 hours, 5 cakes for 1.5 hours, 6 cakes for 2.5 hours, 7 cakes for 1.5 hours, and we have scatter plotted. Draw a trend line. I don't like that trend line. I'm going to retry that. I'm going to cheat. I'm going to use the line tool. That's a giant line. I don't like that line either. Let's use the regular line tool. All right, that looks somewhat reasonable. All right, so again, as long as we've got a line that does not connect the dots, we're good to go. So that looks like it kind of works. I mean, maybe it's not the best one, but it's kind of reasonable. So draw a trend line, yes. What type of correlation does the scatter plot show? Well, we can see that that line has a negative slope. So we're going with negative. What could be an equation for the trend line of the data? So, it looks like if we kept going, we'd be somewhere up around 5, maybe a little bit more than 5. So it could be this one, could be the 8, definitely not the 3.5. The slope is, the y-intercept is definitely not near that. But since I don't know, what I'm going to do is I'm actually going to plug it in, and we're going to see what we got. So let's actually get it. Let's go to stats, edit, and we're going to plug in our data. So we had 2, 3, 5, 6, 7. And then over here in L2, I think it was 4, 4, 1.5, 2.5, 1.5. All right, is that correct? Did we do a good job? 2, 3, 5, 6, 7. Yes. All right, so we're going to go stat over number 4 for our linear regression. We're going to press enter a few times, and we're going to get our value. So let's see what we got here. All right, so which one best matches up with our linear regression here? So I've got a slope of negative 0.529. So I think our winning slopes are going to be the ones that have negative 5.5. So out. We already got rid of that one. And I guess that one's out. So I guess we're done. I guess is the right choice. So there we go. Does that make sense? Well, let's look at our y-intercept, 5.33. Yeah, it's pretty close to 5. That's pretty close to negative 0.5. So that looks like the right answer. Does that look like my line? I mean, not really, but I'm still gonna say that's a decent trend line. It looks like they want something a little bit more flatter than what I drew, but my line is a trend line. It doesn't say to draw the best trend line, just a trend line. And that looks like it goes through the data somewhat decently. So there we go. If we want to do it in Desmos, so we need some new numbers. So we got 2, 3. Oh, that's not good. 5, 6, and 7, and not 3. And then our values over here were 4, 4, 1.5, 2.5, 1.5. And again, I'm not going to type in the code since I already typed it in on a previous problem, but I will steal the answer. And it looks like we're getting the same answer that we did last time. There we go. Looks like we're matching up with what we got with the TI calculator. Ooh, I don't want to do that. Negative 0.5, negative 0.5, 5.133. So again, we're matching with that one. So I would pick that one. That looks pretty good. All right, number 18, we got to find the solution to the system of equations. So to do this one, again, we could just graph them if we really want to. I'm going to do that in a little bit. But if we want to do it by hand, this one's set up very nicely because y is by itself. This is almost exactly like, if we go all the way back, question 2. So it's almost set up like question 2, like a system of equations. Oops. So I go all the way back down here. So what I'm going to do is take the y equals, and I'm going to plug this whole equation in for the y. So I'm going to get 2 parentheses 2x minus 10 equals x minus 8. And now I'm going to solve this one. So we're going to distribute. So 2 times 2 is 4. 2 times negative 10 is negative 20 equals x minus 8. And now I got to do x's on one side, y's on the, or numbers on the other. So I'm thinking the best thing to do here is minus x both sides. So I get 3x minus 20 equals negative 8. All right, then I need to add 20 both sides. So I get 3x equals, that's going to be 12. Then I'm going to divide by 3 both sides. And I get x equals 4. And if I'm feeling bold and confident, I pick the one that starts with 4, and I'm just done with the problem. If I'm not feeling bold and confident, what I do is I say, all right, well, I got 4, so let me take the 4 and let me plug it into this equation right here. Y equals 2 times 4 minus 10. Y equals 8 minus 10. Y equals negative 2, so that checks out with the negative 2. If I'm feeling super unconfident, I'm going to go ahead and just plop it into my Desmos and see what I get. So I don't need this anymore. So I got y equals 2x, completely forgot what it was, minus 10. And Desmos is nice because I can type in 2y. I can just throw that in right away. 2y equals x minus 8. And just like the question we did a couple of questions ago, I just looked to see where they connect. They connect at 4, negative 2. Pretty easy. If I want to use my TI calculator, I can do it in my TI calculator too. The first one I can do, I can just throw it in because it's already y equals. So 2x minus 10. So 2, remember the x button's right here. So 2x minus 10. Now for the second one, I got to do a little bit of work by hand before I can put it in. Since I always need to get them into y equals form. So since it starts as 2y equals x minus 8, to get it where I could put it into the TI calculator, I have to divide everything by 2 because I have to get the y by itself. So y equals x divided by 2, or 1/2 x minus 4. So I can throw that in. I'm just actually going to go ahead and go x over 2 just because that is how it looked. And then minus 4. Then I can graph it. And I can see, okay, they connect right there. I can count 1, 2, 3, 4, 1, 2, and say, yeah, okay, 4, 2. Or second, calculate, and I want to find where they cross. That's the intersection. So I'm going to pick number 5 for intersect. First curve is the blue curve. Yes. Second curve is the red curve. Yes. Guess? Just tell me what the answer is. Just press enter. And then down here, again, we've got our intersection of 4 and negative 2. So again, if we want to do that in our graphing calculator, we have that option. We have that option to double check. But again, we did it by hand. We did it into the calculators, however you want to do it. Final way to do it, if you're super lazy, then you just plug them in and try it. If I plug in 0, does it work for both of them? Well, 2 times 0 is 0. Minus 10 is negative 10. Yep. 0 minus 8. Divide both sides by 2 is not negative 10, so it wouldn't be that one. So I could always just plug in the answers and see which ones actually work. Remember, if you do that, it has to work for both equations. Can't just work for one, it's got to work for both because it's solving the system. All right, for number 19, we got another one of these. What's the solution for the system of equations? So just like the last one, you can do it in any of the methods. So I'm not going to throw it into the graph. Well, I'll throw it into one of the graphing calculators. But I can see that I've got y equals, so I can tell I'm going to take what this is and just plug it in right there for the y. So x minus 2 parentheses 3x plus 14 equals 12. Just like the last one, I'm going to distribute this negative 2. X minus 6x. Negative 2 times 14 is negative 28. I'm going to go ahead and combine my like terms this time. So 1x minus 6x is negative 5x minus 28 equals 12. I can go ahead and add 28 to both sides. So 5x, negative 5x equals, that's 30, 40. Then I can divide both sides by a negative 5 and get x equals negative 8. So I know what x is. So what I'm going to do is I'm going to take the negative 8 and plug it into this equation. Now I could plug it into this one too, but this one already has y by itself, so it's going to be a little bit easier to figure out. 3 times negative 8 plus 14. So that's negative 24 plus 14 or negative 10. So final answer, negative 8, negative 10. And again, if I'm feeling bold, I just leave it as is. If I want to double check myself, which again, it's a test, so you may as well double check yourself. You got the graphing calculator. We're going to throw them in, and we're going to double check to see if we did get the right answer. So x minus 2y equals 12. Y equals 3x plus 14. Is that what it was? Yep. Now, I only see one line, but it just means I got to zoom out to find the other one. So there they are. And I got negative 8, negative 10. And that's exactly what I solved for. So that looks pretty good. I'm actually going to go ahead and just throw that right there to make it easy for me to clip it. There we go. That's where they connect. Since that's where they connect, that's what the answer is. So again, you can do it by hand. You can do it with the graphing calculator. Again, I think by hand is a little bit more relaxing, but if you want to use the calculator to double check, you can use the calculator to double check. All right, last one then. We got a little word problem. So it says a community theater sold a total of 400 full price tickets for adults and children. So we've got a total. So this already looks like it's standard form, because remember, that's our total, and we got two different ideas. So I'm going to do it in standard form. I'm going to make the adults the x and the children the y. So 1x plus 1y is 400, because one adult ticket, the number of adult tickets, and the number of child tickets is $400, or is 400 tickets. So this is our tickets equation. So that means our next equation is going to be probably our money equation. So the price was $8 per adult ticket. So it's $8 for an adult ticket and $5 per children's ticket. So $5 per children's ticket. And we're told that the total revenue is $27.50. So this is the money equation. A lot of times with these ones, those are the two types of equations you want to get. You want to get a something equation and a money equation. So I've got a ticket equation and a money equation. How many adult tickets and how many children's tickets were sold? Now, again, this is set up like a systems of equations. So if we want, we can just throw it into the calculator, find out where these two lines connect. We'll get the answer. Obviously, it's more fun to do them by hand. And this one is set up like an elimination method. So if you remember those, how we did those, what we're going to do is try and eliminate one of the variables. So I'm going to rewrite this as, well, I'm just going to rewrite them over here. Whoops. So 1x plus 1y equals 400, and then 8x plus 5y equals 2750. So for elimination, I need to get rid of one of the variables. I think I'm just going to get rid of the y's. And the only reason is because I think it's going to be easier to multiply this one by negative 5. And then this one I'll multiply by 1. I could choose the negative 8 over here if I want. But remember, I'm going to take this number and just multiply the bottom equation. Take this number and then multiply by the opposite. So that's where I'm getting these numbers from. Again, you can choose a whole bunch of different things, but this is the lazy way to do it to make sure it always works. So let's see. This is going to become negative 5x minus 5y equals negative 2,000. And distributing 1 is nice because I don't actually have to do anything to the equation. So 8x plus 5y equals 2750. And when we do our systems of equations, now that we've done that, we always just add them up. So negative 5x plus 8x is 3x. These are going to cancel to become 0y. And then these are going to become, we're going to end up with 750. To get x by itself, I'll divide everything by 3. Now, I mean, you can tell that that middle term is just going to go away because it's 0. So x equals 250. Because remember, that's just going to be 0. So I know what x is. I know x is 250. So I'm going to take my 250. And again, I can plug it into either one. If I'm looking at my two equations, this one looks like it's a lot easier to solve because there's only one y here. So 1 times 250 plus 1y equals 400. So 250 plus y equals 400 minus 250 on both sides. So y equals 150. Now with this one, and this is where you're going to get in trouble if you make the graph, the answer is not a coordinate pair. We have to actually answer the question. How many adult tickets and how many children's tickets were sold? So for adults, that's definitely not how you spell adult. But for adults, we said that the adults were the X. So that's 250 tickets. For the children, that's the Y. So 150 tickets. Again, we can't write it as a coordinate pair because you haven't told me which one was the adults and which ones are the children. So a coordinate pair would not be a correct answer in this case. Now, if we want to, since we did take our time and set up our equation, we can throw it into our graphing calculator. So I'm going to finish up by doing that. So 1x plus 1y equals 400. And then 8x plus 5y equals 2750. Now, again, since we know what to expect, since we got answers that were in the hundreds, this is pretty useful because it tells us that, yeah, we're going to need to zoom out quite a bit. There we go. All right. Maybe we don't need to zoom out that much, but we get our connection. We just need to find where they connect. And we do get the connection in the same place. So 250, 100. Now, again, we have to be careful. We can't just report that as the answer because that's not the answer. The answer is actually going to need an interpretation. We do need to say what those numbers actually mean. So you have to remember that the 250 is the adults and the 150 is the children. So this is the answer. The answer is not a coordinate pair. We don't write it like we did with the last ones. That's everything that's on the midterm. So midterm is now complete. So there we go.